Don't forget to subscribe and ring that bell.
Welcome to the January 2023 Algebra 2 Regents High School examination. Today's video, we're going to cover problems 1 through 8. We get a calculator for the entirety of the test, so we're going to use the heck out of it, and we're going to own this test. Let's get to work. FYI, this is part 1. Okay, problems 1 through 8. They are part of the multiple choice. There are 24 multiple choice questions in total. Each of them are 2 credits each. There is no partial credit. You are not required to show any work, but will do work where necessary. Problem number 1. Which expression is equivalent to x plus 2 squared minus 5 times x plus 2 plus 6. This is just a basic factoring problem, okay? Sum product, okay? I need 2 things that add to negative 5 that multiply to 6. Now, you might be saying to yourself, Visca, this does not look like it at all. And I can't stand when they do this, but they do it. Let's take x plus 2 out of the equation and replace it with another variable. Let's call it v. V equals x plus 2. So for this x plus 2, I'm going to put a v there. So it's v that's squared minus 5 times when x plus 2, that's a v, plus 6. Now it's a lot easier to see, isn't it? Okay, 2 things that multiply to my positive 6 that add to negative 5. Well, I'm using v's here. I know it's a negative 3 and a negative 2. Okay, both of those numbers, if I multiply them, positive 6. If I combine them, negative 5. Except my answer doesn't have v's in it. Remember, wherever there's a v, I got to put x plus 2 back into the equation. So for this v, it's x plus 2. And now I still have my minus 3, right? And for this v, I have x plus 2, and I still have my minus 2. So, I mean, I'm really just going to simplify this where I can. Okay, I have x, 2 minus 3 is negative 1. And I have my x, the positive 2 and negative 2 cancel. So I really have x times x minus 1. That is choice 1. If, for some odd reason, you could not factor this, you could have, okay? You could have put this whole thing just as it is, you know, without the question mark. We don't want to have the question mark, whatever. We could have put this whole thing in y1. Then I would have tried to put this in y2. I could put this in y2 next. Whatever graph is the same, okay? This would have been the graph that's the same, okay? If that would not have worked, then you try putting the next one in, and so forth, until the graphs end up being the same. But this was a simple factoring problem. Okay, now we are definitely going to use the calculator. If I wanted to, I could do this algebraically. But because this is multiple choice, I'm going to put this side into y1, and I'm going to put this side into y2. All right, so let's go ahead and do just that. Turn this on, we'll go to y equals, and the equation that starts with 4,300 is going to go in the blue. So I have 4,300, that is e raised to the 0.07x. Pop out of the exponent and subtract 123. That's going to equal, okay, the equation we have in red is 5,000. That's going into y2. So 5,000. Now keep in mind, if I just graph this the way it is, my window is 10 by 10. I might not see anything. If your calculator is still graphing, you see this little yellow circle spinning, that means it's still graphing. When that yellow circle goes away, like it did now, it's done graphing. So don't wait around forever. I can't see anything. I only go to 10 on the X, 10 on the Y, negative 10, and negative 10. What I put in Y2, that was 5,000. So I've got to go to at least 5,000. So what I like to do is I go to Zoom Fit. If I'm unsure what to make my window, choice 0 under Zoom is Zoom Fit. And that tends to back out really, really far to the point where we can see everything. Here's our first equation. That's in Y1. And let's see where 5,000 is. Hopefully, there it is. Boom. If I want to see where they're equal, I'm only going to try to find the points of intersection on the x-axis. All right? So I'm going to go to second, trace, and pick intersect. I get close to the intersection points, and I hit enter 3 times. 1, 2, 3. And we have, look at the bottom left of the screen. X is 2.5017. Bring this out here. This is my answer. 2.5017883. If I round 1 decimal place, it's 2.5, which is choice 2. Okay. 3 says the value of an automobile t years after it was purchased is given by the function v equals 38,000 times 0.84t. Which statement is true? Okay, 3 of these will be false. 1 of these will be true. Let's look at choice 1. The value of the car increases by 84%. No, that is false. How do I know that? This value in parentheses, if it is bigger than 1, it's increasing. If it's less than 1, it's decreasing. So since this is less than 1, my function is actually decreasing. Okay, it's not increasing. Okay, so if I look at choice 3, it also tells me it's increasing. That's a no-no. It's decreasing. So let's look at choice 2 and 4. The value of the car decreases by 84% each year. The value of the car decreases by 16%. Please refrain from picking choice 2. I know you see 0.84, and this kind of makes sense. But let's not forget, whatever's in the parenthesis is 1 plus or minus my rate. That's going to equal what's inside the parenthesis. All right? Now, since we're decreasing, we're going to subtract the rate. Right? So all I got to do is solve for r. If I subtract 1 from both sides, I get negative r equals negative 0.16. And if I multiply both sides by a negative 1, okay, my rate of decrease is 0.016. Or if I multiply that times 100, that'll give me the actual percent, which is 16%. Decreases 16% each year. There you go, my friends. Which function represents exponential decay? First of all, okay, just point blank, if something is decaying, when I graph it, it's going to be decreasing, which means it's going to be kind of going down. Okay, that shows a decrease or decay. Okay, if it were going up, this would be increasing. Okay, so they're telling us one of these is going to have decay, so we don't want this. One of them is going to be going downward, okay, like this here. One of them is going to be going downward. So all I'm going to do is I'm going to graph each one of these. I'll put this one in Y1. I will put this one in Y2. I'll put this one in Y3. And I will put this one in Y4. I think I used the right colors for the graph. All right. So let's move this one over here so I can see all my functions. No, I don't want it there, just there. And let's bring this here. So one of these graphs is going to be going down into the right. So let's go to y equals, up, you son of a gun, hit, delete, y equals. All right, and in blue, I'm going to put 1/4, 1 divided by 4, raised to the negative x. That is going to be my blue graph. The red one is 1.8 raised to the negative x. That is my red graph in y2. The next one is 2.3 raised to the 2x. That is in the black line, and the purple line will be my fourth option, which will be 4 raised to x divided by 2. Let's graph this. We still have a 10 by 10 screen. Okay, here's the blue one. That's going up, so it's not blue. The red, come on, red. Where is your red? Come on, red. There it is. That's it. The red one's going down. The other two are going to be going up and to the right. They've got to be. Okay, here comes the black one. There it is. That's almost the same as the blue. It's just a little steeper. And here comes the purple. Where is it? Just for poops and giggles, let's confirm that is also going up as well. So you can tell that the only graph that is going down and to the right is my red one. Okay, and that pretty much answers it. This is the only one that's going down and to the right. The rest of them are going up. Okay, up, up, up. So our choice is the red one, which is choice 2. Oh, I love using the calculator to do these problems. Ooh, I like division with polynomials. I use the reverse tabular. I think I used to do, well, I suppose I can do synthetic here as well. Ooh. Anyways, I'm getting ahead of myself. The expression, x to the 4 minus 5x squared plus 4x plus 14 all over x plus 2 is equivalent to which one of these? If I didn't know how to divide, I could put this, okay, in y1. Then I would just go down the line, meaning I would try this, this board. I would try this in y2. If the graphs were the same, good, okay? If not, then I would try putting this one in y2. If the graphs are the same, then good. If not, then I would just go down the line and see which ones are the same. But I'm going to do division here. Now, I tell my students that you should really only use synthetic division when I'm dividing by 1x plus or minus a number, and I can do that, okay? Or we can use reverse tabular. I think reverse tabular is kind of easy. Synthetic is also easy. So maybe I could do both, but I'm going to go with synthetic division, all right? The first thing I should do is make sure I don't have any missing terms, meaning my biggest exponent is a 4. That means I should have an exponent that's a 4, a 3, a 2, a 1. Then I should have something that has no exponent, okay? So here's my 4. I don't see my 3, but I see a 2 that's an exponent to a 1. This has no exponent. I'm missing x to the 3, so I got to put 0x cubes in between my x to the 4th and my 5x squared. So technically, I have x to the 4th plus 0x cubes minus 5x squared plus 4x plus 14. Now, what I like to do synthetic-wise is I solve for this factor. If I have x plus 2 and I set it equal to 0, x would equal -2. It's this -2 that I'm dividing in. Synthetic division gets rid of all of the variables, meaning it just keeps the big number. That's a 1x squared, so I keep the 1. We have a 0 here. We have a -5. Yes, we got to keep the negative if it's a minus. A 4 and a 14. And I drop. I always drop the first one. Whatever's down here gets multiplied by that number in that little half box. So 1 times -2 is -2. That product gets added to the next term. 0 and -2 is -2. Let's multiply this times my -2. -2 times -2 is a +4. I add it. Let's change it up a little bit here. -5 and 4 is -1. -1 times negative 2 is a positive 2. Let's add them. That gives me 6. Okay. 6 times a negative 2 is negative 12. When I add them, that gives me 2. This last number is always my remainder. Okay. Now, if I were to write this out, if I had to write it back out with my x's here, I would do it as follows. This 6, positive 6, has no x's. This negative 1 has my x to the 1. This negative 2 has my x squared. This 1 has my x cubed. My remainder, since it's positive, plus 2, always goes over what I divided in. I divided in an x plus 2, didn't I? So it should be over x plus 2. This is my answer. And if I look at the 4 answers given, there is only one answer that has the remainder 2 right there. We had a 1, negative 2, negative 1, 6. 1, negative 2, negative 1, 6. God, I love it when math works. We got this test coming up. We got it. Number 6, the sum of the first 20 terms of this series is negative 2. Wow. The sum of the first 22. Yeah. Let me start this over, kids. The sum of the first 20 terms of the series, negative 2, positive 6, negative 18, positive 54, etc., is. First of all, we need to determine, is this going up by the same amount every time? Is there a common difference or a common factor? Okay, is this an arithmetic or a geometric sequence or series? I think if this goes up by a positive 8, I'm not adding 8 to get to the next thing. So it is not arithmetic. I'm multiplying, not adding, to go from term to term. So what do I multiply negative 2 by to get 6? I multiply it times a negative 3. Okay, let's see if this holds. True. Okay, I want to now see, well, what about 6 to negative 18? Is that times a negative 3? It is. Oh, we're looking good. And then 18 to get to 54, a negative 18 times a negative 3 is 50. Okay, good. So we know our common ratio is negative 3. Our first term, okay, is negative 2. In order to do a geometric series, I take my first term, which is negative 2. I put my common ratio in parentheses, and that gets raised to the n minus 1. Now, if I'm going to put this in the calculator, I'm not going to use an n. I'm going to use an x. Okay? Now, they do have a formula to sum up a geometric series on the reference sheet, but I love using the summation. The first 20 terms, so x is going to start to 1 and go to 20. This is what I'm going to put in the calculator, just like this. And I'm going to hit enter and see what it gives me. Turn this on, up again, do delete, bye-bye. Okay, so let's get out of here. I'm going to go to math. And if I go to no, there it is, choice 0. It says summation. I want to start when x is going to be 1 and go all the way to when x is 20. Now, in these parentheses, I write the equation I came up with right here. Okay, negative 2. For the sake of poops and giggles, I hope you guys know, I'm not subtracting 2 from the sum. This goes in the parentheses like this, like that. Okay, so let's do just that, kids. We got negative 2 in parentheses, negative 3 parentheses, raise it to the x minus 1. Let's hit enter. Gosh, that's a big number. But guess what? I don't care. The calculator did it for me. And it looks like that is choice 3, 2AT. Choice 3. Nice. We only have 2 more problems. Number 7. If f of x equals 2x to the 4th minus x cubed minus 16x plus 8, then f of 1/2 is, okay, it's either equal to 0 and 2x plus 1 is a factor. It's either equal to 0 and 2x minus 1 is a factor. Does not equal 0 and 2x plus 1 is not a factor, and does not equal 0, and 2x minus 1 is not a factor. All right, first of all, I'm going to really just address whether it equals 0 or it does not equal 0. Because once I figure that out, okay, I can cross off 2 of these 4 choices. So when I find f of 1/2, that used to be f of x, right? That's telling me I want 1/2 in for every x that's in, better to highlight, that's in my formula for f of x, okay? So if I'm putting a 1/2 in for this x, I got to put a 1/2 in for all these x's, and then I'm going to solve it. So I've got 2 times whatever x is to the 4, that's 1/2, okay? Minus whatever x is cubed, again, we're going to put 1/2 in there, minus 16 times whatever x is, that's 1/2, plus 8. So I hope you can see I'm just putting where the x's were a 1/2. And if I'm going to use a calculator, instead of 1/2, I can put 0.5, okay, which is what I'm going to do so I don't have to create fractions. Okay, it's the same thing. I should get the same answer. Let's clear this out. I've got, okay, 2 times 0.5. We're going to raise that to the 4. Minus 0.5 cubed. No, Visca got a little button clicky happy, and I did not pop off that exponent. Minus 0.5 cubed. All right, then we got minus 16 times 0.5 plus 8. Is that 0? It is. Okay, it is 0, which means if it's going to equal 0, it's either choice 2 or choice 1. It is not 3 or 4. That's saying it does not equal 0. Okay, so now we're getting to the point where, okay, either 2x plus 1 is a factor, or 2x minus 1 is a factor. Now we're moving on to this part. One of these is a factor. I hope you remember that if I plug in a value for x, that's considered a 0. Okay? That's a 0. What does that mean? That means if I had a factor and I solved it, and I set it equal to 0 and solved it, right, I would get my answer. It would be one of the zeros. So they're saying, what did I have up here that when I set it equal to 0 gave me 1/2? Well, let's try 2x plus 1. Okay. If I had 2x plus 1 here, okay, and I say 2x plus 1 equals 0, when I start by subtracting 1, then divide by 2, well, that's negative 1/2. It's not positive 1/2. Okay, so it's not choice 1, it's choice 2. And let's check that just to be safe. Okay, let's check that just to be safe. If I had, wow, if I had 2x minus 1 as a factor, okay, and I set it equal to 0 to solve it, I take 2x minus 1 equal to 0. I add 1 first, so I get 2x equals 1. Then I divide by 2. And there you go. X is 1/2. This will be 0 when I plug it into the equation because it came from this factor. So it is equal to 0, and the 2x minus 1 is the factor. Choice 2. Of course, the last problem is going to have an I in it, and then they're going to throw in this K. But you know what? It's really easy. What do I mean? I have 2 things that are equal to each other. I cannot put this in the calculator. Maybe I could. I probably, no, I'd have to graph it. And I don't know if we graph imaginary, if that would work. Let's do this algebraically, and let's go from there. The only thing that I can do as I look at this is I can just FOIL this out. Okay, I can square this. This, I can't do nothing here. Okay, so I'm going to take, Lord help me today. I'm going to take 6 minus ki and square it, which means I'm going to multiply it times itself. All right? So we have 6 times 6 is 36. Then we have 6 times a negative ki, which is negative 6 ki. Nothing more I can do with that. Okay, we have a negative ki times 6, which is, again, another negative 6 ki. Now, kids, don't blink. A negative times a negative is going to give us a positive. K times K is K squared. And I times I is I squared. All right? The only thing, there's two things I can do here. Okay? Now, let's not forget, it's still equal to 27 minus 36I. Okay? The only two things I could do on the left side is, okay, the 36 I could do nothing with. Negative 6ki and negative 6ki is negative 12ki. Holy smokes. Holy smokes. The holy grail of I is that I squared is negative 1. I see an I squared here. So I'm going to make that just a negative 1. So a positive k squared times negative 1 becomes a negative k squared. Right? This is still going to equal my 27 minus 36i. So you might be saying to yourself, Visca, I still have no clue what's going on. I said it was easy, and here's the easy part. First of all, foiling is easy, okay? But this is the even easier part. As I look on the right side of my equation, I have one term, negative 36, that has an I. When I look on the left side, I only have one term here that has an I. If these two are equal, if the left side is equal to the right side, that means this has to equal this, okay? Or, if you want to do it the other way, there's one term of positive 27 that doesn't have an I. That's on the right side. On the left side, when I combine my terms without an I, I've got 36 minus k squared. So, what does that tell me? That tells me that my numbers that do not have an I should do it this way. When I combine them, should be 27. So I can do this one of two ways. I could take 36 and my negative k squared and set it equal to 27 and solve for k that way. Or, if I wanted to, I could take my negative 12ki and set it equal to negative 36i. I can use either one of these to solve for k, and I'll get the same answer. Why would I pick the k squared? I mean, you can. Some people probably look at that right now and know what it is. But I'm going to pick the one on the right side because there's no k squared. It's just k. If I divide this by negative 12 and I, the i's go bye-bye, the negative 12 goes bye-bye. What I do to the left side, I have to do to the right. What is, okay, the i's cancel. Negative 36 divided by negative 12 is a positive 3. And that answer is choice 3. Now, what happens if I use this side? Okay. Well, if I subtract 36 from both of these, I get negative k squared equals negative 9. If I multiply both sides by negative 1, I get k squared equals a positive 9. Now, here's where you got to be careful here. When I undo a square, it's a plus and minus. So it's both a positive 3 and a negative 3. So I ultimately would have to use the easier side to realize it has to be the positive 3 and not the negative 3. Anyways, when I go up here, there's no choice that has positive and negative 3. I would have to go back to this side anyways. We're done. It took us about almost 30 minutes, but the Algebra 2, it's you know, you're going to need to put some time in it. You have 2 to 3 hours to take this test. And there's only 37 questions. So take your time. Don't go too fast. And you got this.
Don't forget to subscribe and ring that bell.